So, hi and Assalamualaikum. My name is Muhammad Azhar Farizalin, and my supervisor is Professor Dr. Tengi Wah. So, for my data science project, the topic I choose is about visualization for resource efficient monitoring in cloud native environment. So, a little bit introduction to my project. My project have some novelty and relevance where I handle the cloud native environment from a data science perspective. This project is actually the integration of anomaly detection techniques, okay, like isolation forest and LSTM, but with real-time monitoring and interactive visualization. Okay, this project also have some practical value. The application of resource efficient monitoring is actually aligns with current technology. And then this project also have some comprehensive framework because it involves data science methodologies such as data collection, pre-processing, modeling, evaluation, and deployment. And also for model, I did some metric validation to know their accuracy. And for interactivity and usability, I use tools like Streamlit for visualization to enhance the usability of my system. The next, for data science methodology, I use QSDM method. Okay, so let's begin with business understanding and data understanding. For this, we have to do some literature analysis. For literature analysis I did on cloud monitoring system, these are some definition given by each author from their journal. And then these are some existing cloud monitoring tools. I compare them based on the statistical from the author itself, like Ninsoft, Amazon CloudWatch, Azure Watch, and also Prometheus. Prometheus is the cloud monitoring tools that I will use and refer for my project. And then for anomaly detection system, there are some tools highlighted by some of the authors like the correlation analysis, LSTM, and isolation forest. So for this project, I will compare the LSTM and also the isolation forest. And then we come to the problem formulation. So for this part, we have to understand that a cloud environment has a cloud infrastructure, okay, which manage the cloud resources itself. So cloud infrastructure can be divided into three parts, which is the server, storage, and networking resource. For this project, I will focus on server, which is my computer itself. So I will collect the data from my computer. And then to optimize the resource, the strategies that I will use, first I will monitor the cloud infrastructure, especially in server. And then I will improve the visibility with the dashboard. And lastly, I will set up some custom alerts through fault detection system. So these are some metrics that I will look and put it in my dashboard. Okay, so come up with my problem statement. So in today's world, cloud computing is become a technology that delivers scalable and flexible infrastructure which can support a wide range of services. The existence of cloud native environment itself has transformed the way of business. So for this technology, as it's become common among businesses, it grows in complexity. Therefore, we need some proper handling to ensure optimal performance and reliability. So without proper handling, the resources can be overloaded, okay, which cause the system to crash or like bottleneck and in application can happen unnoticed and degrading the performance. So therefore, we need such a proper resource monitoring with fault detection system, okay, assisting with the visualization of the resource, make the better decision making. And this is my project objective. The first one to conduct a literature review on cloud monitoring system and anomaly detection system. The second one to explore and evaluate data processing technique, especially which is relevant to cloud resource monitoring. And the third one to create such an interactive visualization. Okay, in this project I will use Streamlit. And lastly to develop anomaly detection system using machine learning model. Okay, so let's move on to some of the data preparation of my project. So the first part, as you can see, data preparation, I divided into 5 stages, which is data collection, data discovery, data cleaning, structuring, and lastly, the transformation. Okay, so for my data collection, this is the framework. As you can see, I use local device as the server. I scrap it using Windows Exporter, and then I store and pull it in database in Prometheus. And then I pull it using a Python notebook, and lastly, to be stored in the CSV file. But to be note, this is only applicable for model because for visualization, I don't store it in CSV. Instead, I directly query it from Prometheus to ensure the real-time monitoring. So this is some of the process, some query, pull and store. And this is for data discovery part, I did some metadata inspection, okay, for each column, the explanation, okay. For each of these column, there has data type float, okay, which is have their own function. And very useful for visualization. For data discovery, I also did some data head inspection, count missing value and duplicate row because it is important. As you can see, there is not many because only have about 148, the maximum for data missing. And then I calculate some statistical value, mean, median, mode, standard deviation, also range. And then I did some correlation inspection. And lastly, I detect the outliers using Z-score and also based on interquartile range. So I need to do some data cleaning to handle missing value. So I check the percentage of missing value from each column. So as you can see here, the maximum percentage is about 5.7%, okay, which is very, very low, less than 10%. And I did some research based on my data missing value. There are MCR, which is completely missing at random. So it is safe for us to use some mean imputation and row deletion. So the first step I make for the data loss more than 5%, I did some mean computation, and then I'll check again the left, which is left less than 5%, I did some row deletion. And then lastly, I check the percentage missing values again, and it is safe to say that my data has no more missing value. And then I remove some of the null column like network discarded packet, error packet, because all of this has no contribution to data model accuracy later. So it is better for me to just delete this column. And then for data transformation, I did some changes to data format, okay, because timestamp is too complicated with the GMT, which is +8. And then some of the data types are not consistent. Okay, the green flag means they serve the data as a string is rather than a float type. So the decimal places sometimes are not consistent and very too long. And then I did some feature engineering. As you can see, there's this column. This column actually hold value for three type of disk, which is C disk, hard disk volume 1, and hard disk volume 2. So I split this column into 3 more columns to remove data redundancy. And then lastly, I did some key creation because it is important before we split the data for visualization later. And then for model, I did the isolation forest and LSTM. So for model evolution, I compare these two models with the truth drawn using Z-score. Okay, as you can see, isolation forest is better because it have 0.97, and LSTM accuracy is less because it has accuracy 0.92. So for my project framework, this is a little bit about it. I use Cloud Native environment, Prometheus, Grafana, and Alert Manager. So for my project, I did it in the Python workspace where I pull data from Prometheus and then save it in CSV, visualize it using Streamlit, and detect the fault detection using a machine learning model. Okay, so let us continue to the demonstration part. Okay, as you can see, here is my end product using Streamlit. So we have two navigation button, which is home and dashboard. So by default, when people enter this user interface, they will be on the home navigation. So in the home, we have some introduction to my project, why real-time monitoring is important, and also there is another two section which is explain about my data science project, like the workflow, the project frame, and the metric summary. Okay, let us take a look one by one. So for the data science project, here I attach my link to my Canva, okay, where I can explain about my data science project, the background, the problem statement, and another thing. And then for metric summary is actually the guideline of user, how they can use my monitoring tool to detect anomalies. Okay, as you can see here, all of this visualization from my dashboard here with the example of how the fault detection triggers some warning. Okay, as you can see here, all of this visualization, okay, with some problems will be triggered using my machine learning model, okay, which is the isolation forest. Okay, as you can see, the red dot here is the anomalies detected by my fault detection. Okay, as you can see, all of this. Okay, so for each visualization, there will be some explanation or guidelines to the user of how they can interpret this visualization, how to gain insight from it. Okay, so without further ado, let's go to see my dashboard. Okay, it may take some time for running. Okay, so here is my dashboard. The first one, we have a current resources usage, which indicate the current usage of CPU, memory, and also disk. The second visualization is the bandwidth, okay, how much data flow each current time. And then the hard disk usage, okay, how much capacity left for each disk, how much have been used. Okay, and then I have CPU. As you can see here, the red dot here indicates the anomalies, okay, which is the unusual CPU load. Okay, maybe because right now I'm just run my project, so it requires a lot of CPU users. Okay, other than just view the all like this, user can use each of these, making this visualization more interactive. So let us take a look. For example, CPU load interrupt. Okay, here the visualization of CPU load interrupt only. CPU load user, you can see the anomalies, okay? All of this detected using uh, isolation forest. And then I have total swipe, memory detail, CPU usage detail, okay? You can see the anomalies, bandwidth detail, okay? Flow per hour, this read and write. All of these visualization are related to resources that will be implemented in cloud native environment. Okay, and then hard disk I/O total, partition free space, how much left in my RAM, and then services by state. Okay. What makes my data more interesting is because the uses of real-time monitoring. Okay, as you can see, for example, in this chart, the last data scrap at 3:40, right? Okay, so right now the time is already 3:47. Okay, let us refresh the data and see the latest data scrap. It may take some time. Data refresh successfully. So this is the current data. Okay, as you can see, bandwidth has changed. It become reduced. And then here, it's already scrapped until 350. Okay, that's why I said my visualization is interactive and also support real-time monitoring vision. And one more thing, the fault detection system using isolation forest can help to determine the anomalies in my visualization and trigger some warning. Okay, that's all. Thank you.